Hello everybody, my name is Kelly Williams. I'm going to talk about energy flow in deserts today. Alright, one of the things we think about with deserts is that they're very hot. And they are the most arid regions of the world. But one of the big things about deserts is it has more to do with rainfall than it does the heat. That is the distinguishing characteristic of a desert, is that it's just very low rainfall. Located between 15 and 30 degrees latitude on both sides of the equator. So Tropic of Cancer and Capricorn are right there in the middle. Here is a map I found. I was looking for something good that had all of the deserts on it, and mind you, I didn't have time to create one myself, but I thought this was a pretty good one that actually gives the name of each desert, not just kind of puts them all together and says this is one area. Alright, plants, the producers of the desert. Cactaceae, that's a beautiful cactus flower, which I think is actually edible. To humans too. Not sure I'd go get it with all those spikes, but one of the cool things about these producers of the desert, they all usually have this CAM metabolism. Crassulacean and acid metabolism is actually where it came from, and the first plant family they found it in. And you'll think of these plants as succulents, the kind of fat leaf plants, aloe, stone crops. We even have some of those here, but the ones in deserts, they hold water very, very well. The cactuses, trees actually also, acacia, palms, creosote bushes. There's actually a lot of plants in the desert, a lot more than you would think, even flowering plants. They just have to use the right timing. Here is a picture of the acacia tree. This one possibly is in Africa, and they have a really cool dynamic that they live with these ants, and neither species would survive without the other one. It's a very good example of mutualism where they both benefit each other and live together peacefully, and ants will keep any other thing else off of those trees. And here is a creosote bush. I know you don't get to see the whole bush, but I like to have the flowers. I study plants, and that's one of the things you look at when you're actually determining what plant you're looking at. So, Laurea tridentata. All right, plant metabolism is the big deal when it comes to these plants. You've seen most everywhere the C3 plants. It's probably most of the plants. They're rice, wheat, all of the trees. But they have one downfall. Whether or if you're in a cool, wet environment, it's not that big of a deal because you're not losing that much, but they do lose energy to photorespiration when they open their stomatas. C4 have found an interesting way to do it. Corn, sugarcane. They actually use a spatial separation. So they fix CO2 in the mesophyll cells, and then Calvin's cycle takes place in the bundle sheath cells, which basically keeps the process from being reversed so they don't lose any. But that is for a spatial separation. Sunny, hot environments, but not as arid or dry as a desert. And then these are the ones we're talking about today, actually, CAM plants, cactus, succulents, let's see, stone crops, aloe, jades. All these plants use a very cool evolutionary method of temporal separation. Their stomatas open only at night. They open when the temperatures are cooler, and so they don't lose as much water, basically, by them being open. And these are the very hot, dry environments. One thing I think is pretty awesome is the Ford plant in Dearborn, Michigan decided to green their roof, and they redid it, and they planted stone crops, sedum, all over the top of the plant, which holds in temperature. It really makes a big difference in the energy that's being used in the plant, and it gives something there. It's not a big white roof that's just going to reflect energy and light back. So I thought that was a really cool thing to do. But this one, the CAM plants are temporal separated, and that's how they're here. And when we talk about the energy flow, it's the energy flow that you would expect in a lot of ecosystems. It's obviously drier, but there is a lot of production that still goes on there. The photosynthetic plants are the producers, of course. They're the ones that fix the energy. The herbivores, you're going to find insects, rabbits, rodents, things like that. The secondary consumers eat the herbivores, birds, owls, snakes, foxes, and then in turn they're being eaten by tertiary consumers, larger animals. Um, but one thing I wanted to point out is each transfer, you only get about 10% of the energy that you're actually eating. So the green plants have it all. Herbivores are only getting 10%. Then secondaries are getting 10% of that. So there's a lot that you lose in the process of eating meat, although I love it, but that's the truth. And we can't forget our decomposers and detritic feeders, because these guys are awesome. Fungus, microbes, without them we would be standing in a world of bodies and trees and vegetation, and we would have none of the fossil fuels that we are using right now. Not that I'm a big fan of the way we do it, but that's where it comes from. And my last slide is really just a take a look. Here's a picture of really what's going on here. It's more, as any of these, it's a food web. It's not a chain. There's not one link that links things to each other. They are all very complex systems, some more than others, but I thought this was a pretty good one to show. And I like the bird in the top. He's awesome. And here's the works I used. Oh, and the pictures I did cite on there, you can click on most of the pictures and go to them. But there's links for everything in the slide. So thank you very much for your time. You guys have a great evening.